Lesson 4, we have here the thin-walled pressure vessels. A tank or a pipe carrying a fluid or gas under pressure is subjected to tensile forces which resist bursting, developed across longitudinal and transverse sections. So in here, we'll be talking about the tangential stress or the circumferential stress, the longitudinal stress, and the stress in the spherical shell. Pag-usapan muna natin yung tangential stress. Tangential stress is also known as circumferential stress. So in here, we consider the tank shown being subjected to internal pressure P. The length of the tank is L and the wall thickness is T. So if we are going to isolate the right half of the tank, ito yung makikita natin. Now, so this pressure here is exerting pressure on the wall of the tank. So we will take just the horizontal projection and we consider this area, which is the horizontal projection of the inside diameter of the tank. Now, from the idea of the pressure, so the fluid pressure is equal to the force over area, but area here is equal to the diameter multiplied by the length of the tank. So we have here the pressure is equal to force over the product of dl. So we substitute dl to the area, and we have here force is equal to P dl, and this is our equation 1. So in here, the force acting or the total pressure caused by the internal pressure P and the total tension in the wall. So this T here is the tension in the wall. Now we have the tension in the wall is equal to the tensile stress, and we are now talking here for the tension, no, here in the wall and dito sa baba. Now we have here equal to the normal force, that is T, over the area, and this area here is the area of the wall. So this is equal to T, since we know that the area of the wall is thickness multiplied by the length. So this area here we will replace by thickness multiplied by the length. So equating this, and we express this equation in terms of the tension in the wall, we have T is equal to the tensile stress multiplied by the thickness and the length. Now, if we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, we can see here that we have the force F directed to the right. The tensile forces acting in the wall is directed to the left, and dalawa sila. So we have negative 2T is equal to 0. So from here, we could say that F is just equal to 2T. Now substituting the value, since we have here our equation 2 and equation 1, so CF, that is PDL, and we have 2, and the T is the tensile stress multiplied by TL, and if we equate in terms of the tensile stress or the tangential stress, that is equal to P dl over 2TL. But in here, so makakancel si L, and we would have the equation PD over 2T. So, itong formula na to ay gagamitin natin in computing for the tangential stress. Now, if there exists the external pressure, and we denote as PO, and the internal pressure, we denote it by PI. So, from the formula, we have the derived formula. The tangential stress is equal to PD over 2T. So, we would have here the P will be the difference between the internal and the external pressure. So, we would have here PI minus PO multiplied by the diameter over 2T. So, itong formula na to at itong formula na to yung gagamitin natin in solving for the tangential stress. Ngayon, pag-uusapan naman natin yung longitudinal stress. Longitudinal stress is denoted as sigma L. So, we consider a free body diagram in the transverse section of the tank. Okay, so if this is the tank, dun kanina sa tangential stress, this is the cutting plane. And dito naman sa longitudinal stress ay ito naman yung cutting plane natin. So, ibig sabihin, ang kinoconsider natin dito ay yung cross-sectional area. So, we have here the force F acting at the rear of the tank must be equal to the longitudinal stress on the wall PT. No? So, this PT here is the resultant of the longitudinal stress acting here at the wall of the tank. For the area of the wall, that is equal to circumference multiplied by the thickness. And circumference is 2 pi r or pi d. So, we'll be using the diameter. It's pi d multiplied by the thickness, and this is the area of the wall. So, for the force F here, we have, from the idea of the pressure, we have pressure is equal to force over area. So, we have pressure is equal to force. Area is the area that we will be considering is area at the rear of the tank. So, we have area of the circle lang to, that is pi d square over 4. So, if we express this in terms of the force F, so we have F is equal to P multiplied by pi d squared over 4. Then this is our equation 1. Now, for the PT here, kung titingnan natin, we have the longitudinal stress is equal to the force, that is the PT, over the area, and that area is the area of the wall. Ito yung nasa harapan. And we have here the longitudinal stress is equal to PT over the area of the wall, that's pi dt. So if we express this in terms of PT, then we have longitudinal stress pi dt, and this is our equation 2. Now, if we are going to summate forces horizontal is equal to 0, and taking the direction to the right as positive, if in this case ay ito yung x-axis natin and this is directed to the right here, we would have F that is directed to the right, so it's positive, minus PT, which is directed to the left. So we can say that F is just equal to PT. F is equal to P pi d squared over 4, and PT is equal to longitudinal stress pi dt. So expressing this in terms of longitudinal stress, then we would have cancel si pi, cancel yung isang diameter, and we would have PD over 40. And this is our equation for the longitudinal stress. Now, if there exists an external pressure PO, and the internal pressure PI, then we would have the equation for longitudinal stress would be the difference between the internal and external pressure, and this pressure will be PI minus PO, and that's D over 40. Now, let's talk about the relationship between the longitudinal stress and the tangential stress. We have the tangential stress is equal to PD over 2T, and for the longitudinal stress, we have PD over 40. This longitudinal stress here will be 2 longitudinal stress PD over 2T. So we could say that the tangential stress is twice that of the longitudinal stress. So usually nagkakaroon tayo ng confusion whether kailan ba natin gagamitin yung formula ng tangential stress. Sino ba yung, kasi magkahawig yung formula, no, ng tangential at ang longitudinal. Ngayon, ang code ko lang dito, ang pinagkaiba niya kasi 4 at saka 2. So we have 2 and 4. So kung sa length ang pag-uusapan, si 4 is longer compared to 2. So ito, yung may over 4, siya yung longitudinal stress.